Welcome to Insight Builder channel. My dear friends, large language model automators, Python experts, and newly minted vision model enthusiasts. Ultimate vision model, the segment-all model introduced by Facebook. How to use vision segmentation with LangChain. This is going to be the topic of our discussion. Before we actually jump into the topic of our discussion, I want to discuss something very basic. There is something called as a digital barrier or a physical barrier, whichever way you want to call it. Digital world is zeros and ones. You see, it is either there is a color, there is blue, or there is white. When it comes to physical world, there is a continuous spectrum. Okay, and it becomes a big challenge for a computer which works in a digital world to jump the barrier and come to the physical world, which has actually been possible with the help of language models, artificial intelligence models that we are discussing, and also the vision models that we are going to discuss in this video. How it does it? What has happened in the recent past is that the way we actually write the rules in programming, it is always about the rules. So what we do in the programming is that we say, okay, if you are seeing a blue color, then do this. If you are seeing a white color, then do this. Now, when the system is trying to move from this digital world to physical world, this blue and white becomes a little blurry thing, right? So how can you differentiate this color which you are seeing here? Whether it is purely white? No. Whether it is purely blue? No. So how are we going to differentiate that? How are we going to tell it to the computer? Till now, what we are doing is we are hard coding it. So if you are a programmer or if you are a developer, you would know that how the colors are hard coded. And the same way, when you are working with speech or when you are working with translation, so I mean, nowadays it is all automated. So you guys already know about all these models that has been created. I am telling about before all these models came into existence, before large language models, before the neural networks. So the rules were hard coded. You had to write the programs, painstakingly, step by step. But now, with advent of various, language models like GPT-4, the recent GPT-4all language model that has been released, and a lot of people are working on this. But when you as a developer or you as a product designer, you must understand this very basic concept that, okay, what kind of digital barrier I am going to cross with my product. This understanding will give you a very high level overview of how to go about crossing it. So it's a problem, right? We have a barrier means it's a problem. We have to solve it. So that is how we have to start working. Okay. Now, next question. So we are going to discuss about segment-all model, correct? But why to first of all segment? What is the benefit of it? We all know that there is a concept of divide and rule policy that we have read in our old stories, and we have read it in various strategy books and all the stuff. So the same strategy is being applied for the vision analysis also. So segmenting is one of the first task that the vision analysis guys do, so that they can reduce the complexity of the image. So when you divide the image, which contains a lot of things, so if you take a look at this particular image, it is a rose with the stem of the rose, with the background, with the petals, with the snow on top of it, and there is one more rose behind it, and all these are components of this picture, right? And you see this particular abstraction of it, everything has been segregated right now. This is called as segmenting, and this particular segmenting is done almost automatically. It is called automatic zero shot modeling, because by just giving the model, looking at the picture itself, it is able to segment it. This is the breakthrough that has been done by the segment-all model released by Facebook. So we will be seeing how to use it. At the end of the day, I am telling you all this benefit, all these activities it is doing. So how it is going to benefit to you and me. what happens is once you make the model segmented, you actually you segment this part, and then you actually take that segment and give it to the next step, where the next step will be image classification. So you give this image to the next step, image classification model, and it says, okay, this is 90% snow and 10% paper. So we know that, okay, this is snow. This is one of the major benefits that we get by segmenting. We will be seeing that in I'll be showing you the steps that is required. That's very, very important, guys. At the end of the day, now as I was telling you, with this advent of artificial intelligence, we are already jumping the digital barrier to physical world. But how to work in this new world? Because till these days, if you have to do this jumping, you have to write a lot of code and you have to understand a lot of algorithms. But the entire process has been abstracted away. Now you don't need to write those algorithms. The large language models are see, this is a very high level explanation. Large language models are like functions. They are like Python functions that are any language functions that you write, where you give the input to it and it gives an output. This is what the language model does. You give it a prompt and gives you an output. So it is a function, right? That is what I'm trying to say. So the entire functions working has been, you don't need to write a code for that function. So it gets automatically written. So basically it doesn't write code. It actually writes numbers. That numbers, when it is run through the various algorithms, again, which is known to the analysis, machine language experts and artificial intelligence experts and various models they create, then we actually get the jump from the digital world to the physical world. So there are lots of activity goes on. So for jumping this digital to physical world, you have to spend a lot of power, you have to spend a lot of effort and understand and do a lot of things, and then only you will be able to get it. It's not simple. So sometimes it is better not to use this option. So I will be sharing that with you guys today, because always using large language models for simple stuff is going to be waste of effort as well as waste of money. Okay, so with that, let us continue further. Let us think about the use cases. I told you about object detection, image annotation. So this is very useful when you are training the model. You can use it for computer vision, robotic automation, and face detection. So face detection we already see in our own smartphones. We see this face detection, but that face detection is done partly using OpenCV and related functions that has been written using the digital analysis process that most of you folks might be aware of. But what the segmentation models and the artificial intelligence model do is, these models don't actually go and analyze it by using any functions inside the digital analysis realm. They just use the numbers and then decide, okay, this is a snow and this is a paper. So it doesn't know, or it doesn't have the knowledge, or it has not read, for that matter, any of the digital analysis and vision analysis books. No, it has not. It has been just trained. So finally we can use it for video surveillance also. Okay, all these are fine. Where do we use prompts, and what kind of prompts are we going to use? This is the important point that I got surprised myself. See, the prompts for vision model is points or boxes. For us, for the folks who are working with language models, for us, we always think about prompts. At least I think about prompts as series of words or sentences, right? But in case of vision or in case of pictures, it is always about the pixels or the points and the bounding boxes. So when I started understanding this particular model, I wanted to see how it is getting linked. See, my intention is to, as I told you, that as the digital barrier is getting crossed, the way we solve the problem becomes different. Now it is not about writing a lot of algorithm to jump the digital barrier. All you need to know is, okay, what kind of inputs you need to provide so that we can actually get the output that we want. What is output that we want? That we give a picture and we want to get either the text out, or we want to have some kind of activity done, or it could be the opposite. We want to give the text and we get the picture out, and we want some other activities to happen in like a program, like an algorithm. So for that, the initial point is going to be points or boxes. And once we can use these points or boxes to generate masks, And also after the masks have been generated, we can actually use this in all these applications. Okay, so I hope that I have given you a very elaborate explanation. So just bear with me because this has to be explained before we go into code. Code is actually, much more understandable once you know the theory, and I am not giving you all the actual theory that has to be provided. So that will be, way much boring. So I'm not going to go into that. Now coming to the segment-all. So this is Y segment, and we are going to talk about the segment-all model. This actually does one simple activity. It vectorizes the pictures. So it converts the pictures into numbers and gives the numbers to you. This is what the model does, and we'll be seeing how it does in a couple of minutes. And there has been a lot of abstractions already. So we'll be going below the abstraction layer as I was explaining to you. Currently, Facebook AI Research is majorly working on this. Segment Anything library has been already created and released as open source by Facebook AI, and it actually requires a GPU, but in the Colab notebook I have already run it without any GPU and it works okay. It takes time, but it runs, and the model is available for free. There are three models, V8, H, L and B. You guys really don't need to understand what is H, L and B. Okay, at the end of the day, we are going to start with V80H at this moment, and we are going to experiment it. As I say that start by understanding the bare minimum that is required for you guys, because that will actually motivate you to, once you get an output from the input that you're giving, that will actually motivate you to learn more. You will have a baseline where you can start learning. I mean, in fact, the entire artificial intelligence and language models learns that way. Why not us? So that is the best strategy, right? So get the minimum output and then start pushing for the more complicated understanding. Okay, so that is an overview on where it leaves us. It leaves us with LangChain via Replicate. Replicate is one of the libraries and API service that can run the various models, vision models, as well as various language models also. So what I want you guys to do is, take a look at replicate.com and get yourself an account and also an API key. Without that API key, running it will be not possible. You can actually use Hugging Face also, but what I found is replicate.com has lots of models that has been hosted there, and it actually provides a very neat interface to LangChain. So we'll be seeing all these things. Apart from Segment Anything library, there is a library called as Metaseg that has been also written, which abstracts a lot of things away from us. But we'll be seeing that, we'll be using it, but as I was telling you, we go below the abstraction layer, because then only you can understand what is going on. If you are going to use the top level library, you will be getting good looking pictures like this. Okay, you will get, okay, you give this picture, you will get this picture out, but what are you going to do with that? That is more important, correct? At the end of the day, you want to use the picture in some way, or you want to store the data, what will you store then? And how will you use it for the next step? So we will be looking into that a bit. So it starts by converting pics into numbers. So we have Metaseg. So we use this. It's a very simple way of getting the model. So we are going to give the model. We are going to give the points per side and batch, etc. So this is a complete, very high level abstraction. You don't need to know anything about the models. You have to just give this command inside the Google Colab or any of your environment. You should have GPU. You actually don't need to have GPU enabled, but if you have GPU enabled, it works a little faster, and at least you should have 12 GB of RAM. Even it doesn't take that much RAM, we will be seeing that also. Okay, but I'm telling you the baseline, right? And finally we have one important thing: Metaseg or Segment Anything or Replicate Replicate and LangChain doesn't require PyTorch, okay, because they are interacting with the service that is hosted somewhere. But in case of Metaseg and Segment Anything, this is running right in your own processor, in your own computer. Okay, so in that case, you need to have Torch and Torch Vision. So both of these libraries are required. And as I already told in earlier videos, Torch takes a lot of, almost 700 MB of download. Torch Vision takes around 200 MB of download, and also there are lots of additional libraries that comes into picture. So keep this in mind when you are trying to run this in your local environment. With that said, so as you see, Metaseg is it's a high level abstraction. As I told you, you just use this segment auto mask generator, and you will directly get this mask picture. So you don't need to do anything. Everything is done for you, and it is given as a single function. In case of segment anything, which is written by Facebook guys, and it is also released in the GitHub repo, you have to take multiple steps. So you have to get the model first, you have to generate the mask generator, you have to start working with OpenCV2 and read the image, then you have to use a mask generator. So you have to go through a particular series of steps. But this is interesting, guys, because once you know how to generate the mask, then you can actually even predict the mask also. So we will be seeing how it works in reality. So that is where you will understand, okay, so this is what that this is the process that is going on. And finally, we have replicate. A replicate is a library and a service, as I was explaining, where you can give the model name and you can give the image, and it will give the output, and the output will be stored in the cloud. So you can pull it from the cloud by using wget. This also I'll be showing. So you saw the three options, but now the most important thing is you will be still wondering, okay, where is the prompt? What kind of prompt am I going to give? So here is your answer. So we can actually give the prompt like a point. So we give a NumPy array and we give this point location inside the picture, and we will see how is this point located. We also can label it. We can label this particular area as 1, and like this you can label the entire. So what is labeling? Let me explain. So we can say this is number 1, label number 1, this is label 2, this is label 3, this is label 4, this stem is label 5, this is label 6, and the environment is label 7. All these things you can actually do it manually also, and you can actually automate it also. So any which way you want to do, you can do that. So understanding this process is important as you start working with multiple images. Okay, now you must be knowing, okay, so if I take an image and if I give a point to it and if I label it, then these two things will work together. And after that, I can use the predictor.predict, and I can get the mask of that location, of this location. This is the important point I wanted to highlight. This slide is actually the important slide, if you ask me. And we are using SAM predictor class for this. Okay, so this is all theory. Okay, and this is about using segment anything from Facebook. Now we can actually use replicate along with LangChain as LLMs also. And once you make LangChain LLMs using replicate, you can place this LLM inside the chains, the LLM chains again. So you can use it for calling multiple different steps. So for an example, I can use the segment anything on the rosebud, and I can get the output like this. And also I can use Stability AI's stable diffusion model inside the LLM, and I can get the output of this particular picture. I got it after I prompted it, telling that, okay, give me a picture that shows King Kong driving a bike. So you see the output. So it looks very much like King Kong driving a bike. And at the end of the day, we can do this all, and inside the LangChain environment itself, you can get the picture out. So yeah, we are not going to, the LangChain does not have any kind of image capability. What it does is it is calling the replicate API, and the replicate API sends you back the picture location. So couple of steps has been abstracted by the LangChain library. Okay, so this is the overall picture that I wanted to show you guys, and also the code that is going to be run here in the Colab environment will also download a couple of models, which is 1 to 4 GB in size, and also the segment anything example. So most of this ideas, this code, I got it from this particular link. So I'll be sharing this Facebook segment anything example notebooks. That is very important, guys. It is better that you guys actually take a look at this particular example to understand more about this segment anything model. With that said, we'll be going to the we'll be going to the Colab environment and start practicing and understand how the things work. So I hope that you like this video. Do leave a like and share it with others, and most importantly, subscribe so that any further discussion on the artificial intelligence model with respect to LangChain and big data related concepts will be directly sent to your YouTube dashboard. With that said, let us go to the browser. if you guys are new, in fact, if you are coming to this channel through any of the search option, and if you are new to the AI language models and LangChain, take a look at this playlist. You'll get up to speed in no time. Okay. And when it comes to the repo, the particular exploration of Metasig, I have placed it inside the Python DE learners data under SAM_exploration folder. So I'll be sharing this link also with you guys, so you don't need to worry about. And this particular repo is Facebook research, where I got all the information from the predictor_example.ipynp. This is little more, it involves lots of theory, okay, which I explained to you. So you can, I urge you that you go through this also and you get more clarity on what is going on. So you can take a look at that. And finally, we have, LangChain interface with Replicate. So all this are available in the LangChain's documentation. And this is a pretty new release that has been done. I think it is in the release version 131 or 130. I'm not exactly sure. So they released it pretty recently. So they have done a very good job. We can actually send it through a chain here. All these things I will be explaining. I'm just showing it to you. So here is the first chain that uses the you see the model here. So this model is coming from Replicate, and this Replicate model is a LLM1, and we are using that LLM for LLM chain 1, chain 2, and chain 3. So that is how the model is getting chained. This should actually give you an idea right now. So by using the prompt, you are actually getting the image. Now you saw that if you have seen GPT-4 working, you must have seen the images coming out, right? You don't need the large language models for that. You can use simple functions also. This is what I was telling you. So for all the activities, you don't need large language models. Okay, so don't take that much big of a hammer and hit a small nail. You will hit your fingers. So ensure that you sometimes you have to work precisely, and for that working precisely, the best tool is working with programming languages like Python, JavaScript, Java, C++. Okay, large language models are like heavy lifters. So you give it a huge amount of data, and they do a lot of activity inside their model, and they give you good output. Okay, but if you want precision, if you want to control the output very, very strictly, then resort to programming. I mean, programming is not dead, guys. Programming is way more important right now than any other era that we lived, because programming is not about languages. It is about the way you think. It is about how we execute stuff. And till this universe is going to be there, we are going to execute stuff. So whether we are there or not, universe will start executing it, right? So programming, or for that matter, programming languages are way far away from being dead. Okay, so let us not even think in that way, and use the programming functions whenever it is possible, so that you can save cost, you can save time, you can avoid wasting energy by calling large language models. So there are certain times it is better to use functions. Okay, so these are all the points I wanted to share with you guys, and I'll be jumping into the Colab environment. Colab environment is already set up, and first I will be pip installing Metasig. So let it connect and let it initialize. I will be initializing a regular RAM and CPU processor only. I will not be taking any kind of I will not be using any kind of GPU. As you are seeing here, it will be little time consuming. I will be pausing the video when the process starts. So I just want to show you guys that you don't need a GPU to work it out. And as you can already see that GPU itself is a cost, correct? And when a lot of people are going to use this model, use the model in your product or in your service, probably you will need a GPU and a high performance machine with good connectivity. I'm not denying that, but you are going to learn right now. You are going to understand the model. There, it is always better to have bare minimum, as I always say, bare minimum specification to actually test it out, to really understand what is going on behind the scenes. So already the setup is already kept. So this is the picture that I've already downloaded from this particular Pixabay website. huge shout out to Pixabay for holding out all these pictures for us. And then we get the image directly into this particular output. We get this rosebud JPG here. And Metaseg is very simple. So once you start using Metaseg, you just use the segment auto mask generator class, and you save the image. And once you do this, you immediately start getting the output. So this output JPEG is this is the output JPEG that you'll get. Yeah, it's just 2 lines of code. So a lot of things have been abstracted, and you see the color is totally different, right? Whatever I showed to you in the other pictures. So Metaseg has been colored. I mean, it has a very natural looking color masking. While I'll be showing one more example that is not so natural. So it is very cartoonish. See, at the end of the day, for a computer, it doesn't matter. Computer does not even realize there is a color. It just sees the number. Okay. For humans, yes. So it will be better to have a look at this aesthetically pleasing picture, but that's just aesthetics. And this is the research that I was talking about. So this link is already there in the the notebook also. Once you download this, pip install this particular repo, then you can start working with SAM predictor, model registry, automatic mask generator. This automatic mask generator and this auto mask generator are totally different. Okay, this is coming from Metaseg, while this is coming from segment all. So keep that in mind. Segment anything. So I have been telling segment all, it's segment anything. Very sorry for that. Okay, what I'm going to do here is that I have to call the segment model registry, and I have to give the particular this model. This model has already got downloaded. So when I call this auto mask generator, this calls the model type, and this function itself actually pulls down the model. Okay, so don't be surprised that to see almost 1.1 or 1.2 GB of data downloaded. So once you call this function, it will immediately download. So try this out inside the Colab notebook before you go into Python script. That will be, it will save you a lot of headache. And then what we are going to do is, so we are going to use a SAM mask generator. So this will initialize the mask generator on top of this particular model that we downloaded. After we generate that, we are using the OpenCV to read the same. We are going to read the same rosebud image, and then we are going to generate the mask. So once you generate the mask, then you start seeing the numbers. So you start seeing the area, you start seeing the bounding box, you start seeing the various coordinates and all these things on the mask. And there are support functions that has been written by the Facebook guys. These are all the support functions. So we can show mask, we can show points and show box. All these things, it's actually separate. It is you are able to see this. But all these functions have been completely abstracted by Metaseg library. Okay, so you are not seeing all these things. It is done for you and it is automated for you. But whenever I am discussing something, I actually go below the abstraction layer and tell you what exactly happens, so that when you are trying to implement, when you are trying to use this particular model or particular concept, it will be way more easier for you. So that is the main objective of going like this. And this is one of the places where we start working on SAM predictor. So this is mask generator. This just generates a mask. But what happens with the predictor is we will be seeing it. So in the case of the predictor, we give the prompt, we give a point, and also we give a label. And so now you see that I am actually reading the picture using matplotlib.im show, and then I am showing the points. So you see the point here. This is the point where I am prompting it. So I am asking, okay, mask this location. So that is what I am going to do. So this is an example that I am showing. And then I'm using this masks, scores, and logits, and I'm going to call predictor.predict. I'll be giving the input point, label, and the output. So it is a multi-mask output. So I'm going to give it as true. Once you execute it, you will see that you will get lots of. Wait a minute. Let me show you by checking the length of logits. So this is how you check inside the Python environment. Okay, you don't need to remember. So you see that we are getting 3 as output. So it is not one logits that you are going to get. It's going to be 3 different three different arrays of numbers. So out of that, the first number is what you are seeing here. As I was explaining to you, that it is going to, let us go to the presentation for a moment. We are actually creating numbers, right? So converting pics into numbers. This is what our final aim is. That is what the model does. It does not do anything apart from that. Let us go back to the browser. So you see that numbers out, and you can use these numbers for the next step that you are going to do. But you actually don't need to do it manually. So I'll be showing, as I already explained in the LangChain chain related concept, you can chain the output from one particular artificial intelligence model to the another one by using the LangChain interface also. So that is one of the benefits of LangChain. And here we are going to see the actual picture. So you see the mask here. So this is in blue color, and you see that it will also show the score. So this is a score which is actually lower. It is masking this entire bud, but here it is actually masking the proper snow area, and it is giving 1.008. And also there is one more. So here it is masking everything, and this has a lower score. Okay, so this is what we are talking about, and this is actually called as prompting. So when you give a particular location and you get a mask around it. So for an example, if you move this to here, so if you move this point to here, you can experiment this. So going back to the presentation, the point again and again I tell when I end my presentation that you have to practice. So the interesting part of doing the practice is you can start playing around with it. So I should say start playing, but it doesn't sound very serious, right? So that's why I say practice. Let us go back to the browser, and so you can start playing around with this number. So how will you play around with this number? Very simple. You go up about here and you start changing it. So I can show it to you guys. It's better that way. I will change it. So we are in 500 in X and 375. So I will say I'm going to take 450. Let me take 400, and also I will increase the height a little. Okay, and I'm going to change this. And once I change this, I'm going to see the output here. You can actually play around with this inside the Streamlit library, inside the other libraries also. So you can try it out. You see here, now I have moved this point from here to here. So I have moved it out, correct? Next, what I'm going to do is, and you see this number here. So this is all created by Matplotlib. So you know what is going on. So I moved it, down. So it is 400 in X, and in case of Y-axis, it is in case of Y-axis, how much it is? 475. Okay, so I've already done that. So from the top, it is 475. You see that, right? From the top, not from the bottom. Now I'm going to repredict it. Okay, I'm going to repredict it for you guys. And it is all being done inside the Colab notebook only. It's not going out. And I'm going to enumerate it again. So I'm going to show you guys how it changes and what location gets masked right now. So you see this. So you see the change here. So previously it had masked the entire this entire bud, but now it is masking a different location with a different scores. You see the score here. It is 0.96. So this is what I was telling, and now you see that it is actually demarking the entire thing. The entire background has been demarked. This is what I was telling. Now you know that we are actually clicking at the background, so it masks the entire background. Once you know that this entire background has been masked and you take it out, then you can start using it in your other next steps. You have to see this physically, then only you will understand that. So start playing around. Now we are going to enter into LangChain. We are going to import replicate. We are going to import LangChain, and replicate token. You have to get the API key and place it here. I am not going to go into deep in this. It's a very simple process, guys. Just go to API replicate website and pull the API keys. It's very simple, and you can start running. So this particular repo, Pablo Dawson, thanks for Mr. Pablo Dawson. We can again run the segment anything from the replicate, and we can get the output. Okay, and the output actually comes like a comes as a link. So I can use the wget here, and I can get the output. I can get the image, and this is the image that we get once you send it to replicate. So this output is different from what you saw here, right? Because this has been this particular segment, anything automatic, has been written by someone else called Pablo Dawson. Okay, he has actually changed the settings inside. He has worked out the ways of coloring it and all those stuff. He has changed it, so that's why you see it differently. But it is hosted in the internet, so it is not hosted internally to your Colab notebook. Okay, that is a difference. If you are going to, if you need it, you can use it. And here we need it, because why we need it? we are needing it because we are going to use it in LangChain, right? In order to use the segment-all model, we want to actually pull in the LLM from the replicate. So this is how you actually initiate that in LangChain. Okay, so what is the difference? So you might be thinking, Kamal, what is the difference? So here we are saying replicate run, and we are directly giving the model. But here what we are doing is we are importing replicate with capital R from langchain.llm, and then we are using the model. And we are not stopping there. We are placing the model, and then we are giving it a prompt. And so this is a stable diffusion that I'm giving an example. So don't, I completely forgot to inform you guys. This is not segment-all. This is stability-AI stable diffusion model, which will take the text as input and give you image output. So you see the image output here. So the input is King Kong riding a motorcycle by Picasso. So this is Picasso. That's what the model thinks. And this is the output that you get. The output comes as a link. So the same way, when you are going to work with various chains in LLM, so we saw that we can actually use this LLM. So once you create this replicate, this is actually I will show it to you in a moment. I will. So let us actually use type, and we say text to image, and if you see the type of it, you will see that it is an LLM from LangChain. So this LLM you can start using in LLM chain. And there are already examples available inside LangChain, so I am not trying to replicate it. The most important point is how you use it. The better you understand the basics of it, now you know how the actual steps works. So probably we'll start with the prompt. Where is it? Sorry. Yeah, you start with the prompt, and then you can use the output image and send it to the classification model, and you can classify it, or you can actually again ask for image to text conversion. You can do a lot of things in this way by using replicate as well as LangChain. So take a look at that, play with it. I hope that you guys have got a fair idea on what is going on with segment-all, as well as with the various steps that is involved in segmenting. Also, the most important point is understanding how the language models are jumping the barrier from the digital world to physical world. What are the drawbacks and what are the benefits of it? All these things are very important steps that you need to understand. So go through this video if you want again. But most important thing, as I always say, is that you guys have to practice to see what is going on. As I showed you, move around the location of the point and use a different picture. Work with multiple pictures. See what you can do when you try to implement the series of steps. Like for an example, using LangChain's LLM chain, multiple LLM chains, or agent executors. You can do all this steps, and you can use with along with OpenAI's ChatGPT also. This is a couple of ideas that I was thinking in my mind. So with this, guys, I would like to conclude the video as usual with 4 words: that continuously practice, guys. So practice, 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 practice. See you. Have a great time.